A clutch is a mechanical device used in the transmission system of a vehicle. It engages and disengages the transmission system from the engine. It is fixed between the engine and the transmission. Friction disc. These discs are attached to the driven shaft and are essential in allowing the driven and driving shafts to change directions. The friction created between the discs helps in the transfer of power. Pressure plate. The most important component of the entire clutch assembly is the pressure plate. It applies a clamping force, pressure, to the driven friction disc which holds it between it and the flywheel. The pressure plate is bolted to the flywheel and rotates together. Clutch plate. The friction between the pressure plate and the flywheel plate causes the clutch plate to spin together with the flywheel, which rotates the shaft and the attached transmission. Spring and release lever. In clutches, diaphragm springs are often used to supply the required spring force. These springs are operated by levers. The force applied to the spring during clutch disengagement is significantly reduced by the release lever. The clutch mechanism can be smoothly disengaged by pulling the release lever, which lowers the stress on the diaphragm spring. Flywheel. The flywheel functions as an energy storage component, storing excess power and releasing it back into the system as needed. It usually connects to the crankshaft and keeps turning while the engine is running. Release bearing. Clutch release bearings are utilized to transfer or limit the driving force. The high-speed rotating diaphragm spring exerts a tremendous force on the clutch release bearing when the driving force is cut off, causing the bearing to rotate rapidly. Diaphragm spring. The diaphragm spring, being one of the key components of the clutch, produces pressure force for the clutch. It also allows for clutch engagement and disengagement. Diaphragm springs are dynamically loaded while they are operating. The clutch works on the principles of friction. When two friction surfaces are brought in contact with each other and pressed, they are united due to the friction between them. If one is revolved, the other will also revolve. The friction between the two surfaces depends upon the area of the surfaces, the pressure applied upon them, and the coefficient of friction of the surface materials. The two surfaces can be separated and brought into contact when required. One surface is considered as a driving member and the other as a driven member. The driving member is kept rotating. When the driven member is brought in contact with the driving member, it also starts rotating. When the driven member is separated from the driving member, it stops revolving. This is how a clutch operates. The friction surfaces of the clutch are so designed that the driven member slips on the driving member when the pressure is first applied. As pressure increases, the driven member is brought slowly to the speed of the driving member. When the speeds of the members become equal, there's no slip, the two members are in firm contact and the clutch is now fully engaged. The driving member of a clutch is the flywheel. It is mounted on the crankshaft. The driven member is the pressure plate. This is mounted on the transmission shaft. The clutch plates are between the two members. When the clutch is engaged, the engine is to the rear wheels through the transmission system. When the clutch is disengaged by pushing the clutch pedal, the engine is disconnected from the transmission. Thus, the power stops flowing to the rear wheels while the engine is still running.